Hello, welcome to another edition of TutorTube, where Learning Center's lead tutors help you understand challenging course concepts with easy-to-understand videos. My name is Kelly Schmidt, lead tutor for Statistics at the Learning Center. In today's video, we'll go through the process of conducting a paired samples or dependent samples t-test in SPSS and Excel. Let's get started. First, let's look at a research scenario. In this situation, we're interested in testing the effectiveness of an after-school math program for 5th graders. We administer a pretest to 12 students before a month-long intervention, and then a post-test immediately following the program's end. At first, you might be tempted to use an independent samples t-test to compare the means of these groups. Unfortunately, that kind of test doesn't work here. Our samples, the pretest and the post-test, are not independent. The same students are measured in each group, making this a dependent test. As such, we need to do a paired samples test instead. So first, start by opening up a blank datasheet in SPSS. Be sure you're in Data View instead of Variable View. Data View is the place where we enter all of the raw data that we're given. So let's copy and paste our scores into the sheet. Notice that when we first copy them in, SPSS automatically labels the columns as scale variables, called var 0001 and var 0002. And remember that SPSS treats each row as a single person, so we can check to make sure we have 12 rows or 12 students. Next, click on Variable View to switch to the Variable Coding window. This is the place where we name our variables and specify their measures and labels. We can start by clicking on the name column and renaming var 0001 as pretest and var 002 as post-test. Next, we can go to the measure column and code each variable as scale. Unlike an independent samples t-test, we don't need to specify labels for groups here. Also, be sure that each variable is coded as numeric under type. We can switch back into Data View to see how our data has changed. Notice that the columns are now labeled correctly. Now we're ready to do our analysis. Click on Analyze, Compare Means, Paired Samples t-test. Once we get to this window, we need to choose the order that we want SPSS to use when comparing the pretest and post-test variables. Usually we go with an after minus before model for these tests because this lets us see more easily if scores have improved. So start by moving post-test into the variable 1 box and then move pretest into the variable 2 box. From here, we don't need to change anything else. We can just hit OK. This will bring up our output window. The first box shows the descriptive statistics for the test. We can see that the mean of the post-test was about 7 points higher than the mean of the pretest. The paired samples test box gives us the information we need to answer our research question. First, we can see that the mean of the different scores was 7.333 with a standard deviation of 6.93. So on average, there was a 7.33 increase per student. In order to determine if this increase was statistically significant, we need to look at the last box labeled SIG two-tailed. This gives us the p-value, the p-calc for the test. Because our p-value of 0.004 is less than the standard significance level of 0.05, we can say that there is a statistically significant difference in scores between the pretest and post-test. In other words, there's evidence here to suggest that our intervention program had an effect. Next, we can look at the effect size of the test to determine how impactful the increase in scores actually was. Looking at the Cohen's d point estimate, we can see that there is a large effect size at 0.058. When interpreting Cohen's d, a general rule of thumb is that anything smaller than 0.2 is considered a small effect, and anything larger than 0.8 is considered large. Since our p-value of 1.058 is bigger than 0.8, we can say that the difference in scores between the pre-test and post-test groups was noticeably different from 0, which is an indication that our math intervention program might have been really good. SPSS is a good tool for this analysis, but if you want to get an idea of the mechanics behind the calculations, you can also get the same results in Excel. First, paste the data into an empty sheet. Next, we're going to create a new column containing the after minus before difference scores. I'll label this as after minus before. In the first empty cell, type an equal sign. Next, click on the box containing the first post-test score, type a minus sign, then click on the cell with the first score for pre-test. Hit enter, and notice that the formula subtracted the two values to give us 20. Next, click on the black cross in the corner of the box and drag it down to copy the formula to the cells. Now we need to find our test statistic. The formula for this is here, where d bar is the mean of the paired difference scores that we just found, s is the sample standard deviation of the different scores, and n is the sample size. To find the mean of the scores, I'll pick an empty cell and type equals average, parentheses, and then highlight my column and press enter. This will give us the mean difference, d bar. Next, I'll pick another empty cell and type equals stdev.s, parentheses, and highlight the column again. This will give me my sample standard deviation. My sample size, n, is 12 because I have 12 students and 12 scores here. Now I'll find my t-statistic by building the formula. If you wanted to, you could plug these numbers into a standard calculator, but we can do it in Excel too. In another cell, type equals, and then click on the value for our mean, type a division sign, and then parentheses, click on the value for standard deviation, type another division sign, and then type SQRT, parentheses, and click on the value for n. Finally, we type 2 close parentheses and hit enter. This will give us our t-statistic of 3.664, which is exactly the same number that SPSS calculated. Finally, we can calculate our two-tailed p-value. In another cell, type equals t.dist.2t for two-tailed. Click on our t-statistic, type a comma. For degrees of freedom, we need n minus 1. And once we hit enter, we see that the p-value is 0.0037, which rounds to the same value that SPSS found of 0.004. And that is all there is to it. Thank you for watching this TutorTube presentation. I hope you enjoyed this video. Please subscribe to our channel for more exciting videos. Check out the links in the description below for more information about the Learning Center, and follow us on social media. See you next time.